Hello everyone, today we're looking at Unit 2, Lesson 6, Medians, Altitudes, and Perpendicular Bisectors. So these are different types of lines we use in geometry that intersect or cut lines in a triangle or just a line in general in a certain kind of way. So we're going to discuss how we go about finding the equation of these lines based on what we know about slope, midpoint, lines being perpendicular to each other. We're kind of going to pull together all that information that we've learned so far to help us work through these problems. So first of all, let's look at if we had a median. What is a median? So a median is a line that is going to cut from a vertex. We're going to say from vertex A, and it's going to cut to the midpoint. I'm going to try that again because it didn't look very straight. Cut from the vertex to the midpoint of the line across from it. So this side of the midpoint and this side of the midpoint, they're going to be the same distance, all right? And we're going to call this vertex A. And so we drew a median from that vertex, so from vertex A. So we'll just write up here what a median is. So a median is a line that joins the vertex of a triangle to the midpoint of the opposite side. Okay, so we're going to figure out how do we go about finding the equation of a median. So today we're always looking at how do we find the equation of these different types of lines that we use in geometry. So we're trying to find the equation of a median. Okay, so step one, we're going to write our steps in this other box. Okay, we're going to find the midpoint of BC. So we're going to find midpoint of line BC. Once we find the midpoint of BC, that's going to give us a point on our line, right? Our median line. From there, we can find the slope of the median. Using vertex A, because that would be 1 point on the line, and the midpoint that we just calculated in step number 1, because that would be another point on the line. And when we have 2 points on a line, we know we can find slope. Okay, so once we have the slope of that line, we can solve the equation for our y-intercept. So solve the equation for your b value, which is our y-intercept, remember, for the median line. Remember, the whole point of this is we're finding the equation of our median line, not any of the sides of our triangle. And then finally, once we have our slope, once we have our y-intercept, the only thing left to do is write the equation. So let's take a look at an example, and we'll even do a rough sketch of this triangle, so it'll hopefully help us see what we're doing. So it says, find the equation of the median line from vertex E in triangle DEF if vertices are D is at -1, 2, E is at 3, -3, and F is at 5, 4. So I'm just going to draw a rough sketch of this triangle. So if we had it on our Cartesian plane here, so D is at -1, 2. So we'll say D at -1 and 2. And then we have E is at 3, say -3, somewhere down here. And we have point F at 5 and 4. Okay, and then I'm just going to draw a rough sketch of that triangle. We're not trying to measure anything with preciseness because we're going to calculate everything algebraically, so it's okay to do a rough sketch. It says we're going to find the equation of the median line, so I'm just going to draw the line that we're going to find an equation for in a different color. So from vertex E, so we know if it's coming from vertex E, it's going to cut DF in half, right? It's going to cut this in half. So this side is the same as this side of that triangle. So if we wanted to, we could try to figure out that midpoint, figure out that point right there. So that's step one. Let's find the midpoint of side DF. So midpoint of DF is equal to, and remember, we're just going to take the average of our x values and the average of our y values. So our x values for D and F are -1 plus 5 divided by 2, and our y values are 2 plus 4 divided by 2. So the midpoint of DF is going to be equal to, well, -1 plus 5 is 4, plus, or divided by 2 is 2, and then 2 plus 4 is 6, divided by 2 is 3. Okay, so that will be our midpoint. Let's give this a point. Let's give it a name. So let's call this point G. Okay, so I'm just going to label it up here. So we'll say that we have point G at 2, 3. So now we can see that we have some information about this line that we're working to find the equation for, right? We have this point on the line, and we have this point on the line. So once we have 2 points on the line, we can use those 2 points to find our slope, and that's step 2. So we're going to find the slope of the median line, which is EG, right? Those are the 2 points we have right now, so we'll work to find the slope. So my slope is going to be the change in my y values. So I have, for my y values, I have a -3 minus 3, and my x values are 3 minus 2. So we'll have a -6 over 1, so we'll just have -6 for our slope. Now we know from our linear relations unit and linear systems unit that we need slope and y-intercept. So I have my slope, I need to find my y-intercept. So that's our third step. We're going to find the b value for the equation of the median line. So we can sub in the information we have. We can sub in a point. We'll sub in vertex E, because that was the point given to us, and we'll sub in our slope. So remember, the equation of our line is y equals mx plus b. So the y value from vertex E is -3. Our slope we calculated was -6. The x from vertex E is 3, and then we have to work to find b. So we'll just simplify, and then we're going to move that 18 over by adding it. So -3 plus 18 is going to be 15 equals b. Okay, if I have my slope, if I have my y-intercept, the last step is to write the equation. So you can say, therefore, the equation of the median line is y equals -6x plus 15. Okay, so that's how we found the equation. Okay, let's take a look at another type of line that we use in geometry. It's called an altitude. So this time our altitude is going to be, if we were to draw from our vertex A again, and we're going to draw straight down, so you can see it's not really going to cut BC in half, but what it is going to do is it's going to make this 90-degree angle. So just like above, just so we're kind of always coming back to that same reference, we're drawing this altitude again from vertex A. Okay, and this is my vertex A. All right, and you can see that the altitude makes a 90-degree angle, a 90-degree corner that's perpendicular to side BC. Right? When they meet at 90 degrees, it means they're perpendicular. So let's just define what an altitude is. So an altitude is a line that joins the vertex of a triangle to the opposite side at a 90-degree angle. So it makes that perpendicular corner. Okay, so in this case, now we're working to find the equation of our altitude. So So just like above, we're now working, how do I find the equation of this altitude? So I have to think about what information can I get from this line I just drew in the triangle. We have a point right now, but we don't have any other information. So how can I work towards it, maybe finding the slope of this line I've drawn? So if we know it's perpendicular to BC, let's start with that. Let's start with, we're going to find the slope of BC. Okay, so once we've determined the slope of BC, then we should be able to determine the slope of that of that altitude. So find the slope of the altitude. And remember that it's going to be a negative reciprocal because it's perpendicular to BC. All right, so once we have the slope of the altitude line, just like above, once we have the slope, we need to solve for our B value, which once again is our y-intercept for the altitude line. And then once we have our B value and we found our slope earlier, we should be able to just write the equation. So let's take a look at an example and see if we can kind of follow through these steps. So it says find the equation of the altitude from vertex A in triangle ABC. So let's see if we can draw this. I'm going to draw my coordinates again. So we have point A that's at -3, 4. Just find it helpful to put the coordinates on here so then when we're trying to refer to certain points on a line, they're right next to their points. So B is at 0, -2. That's a negative. And then C is at 4 and 6, somewhere up here. Okay, so we'll just draw a rough triangle here. Doesn't have to be perfect. Okay, it says find the equation. So we're finding the equation of the altitude from vertex A. So we know, I'm going to draw it in a different color again. I'm going to work to find the equation of this red line I'm drawing. And an altitude, trying to draw it so it looks like it, is going to be a line such that it cuts BC perpendicularly. So it cuts it at a 90-degree angle. So step 1 says we're going to find our slope of BC. So let's do that. So let's find slope of BC. So between B and C, it's going to be the change in my y values. So I'll have a -2 minus 6. And I'll have 0 minus 4. So my slope will be a -8 over a -4, which will simplify to a +2. Okay, so that's for BC. We need to find a slope of our altitude. Let's give this point, so that we have 2 points on line, let's give it a name. So we will call this point D. So let's call this point D. And it's just the point where the altitude meets line BC, so then we have 2 points on that line. So now that we have the slope of CB or BC, we can find our slope of AD, right? So AD, remember, is my altitude. Okay, so since we know it's going to be perpendicular to BC, we can just take that slope we just found in the previous step and we can take its negative reciprocal. So we're going to flip it and we're going to change the sign. So I'm going to uncircle this because this is not the slope that we want to use for our equation. That's just our first slope we found. So the negative reciprocal slope is going to be a -1/2. I'm going to circle that one. Okay, step 3, now that we have our slope, we can use a slope and a point to help us find our B value. So let's find our B value for the equation of our altitude. Okay, and I'm going to sub in, we pretty much always will have a point and the slope. So we're going to sub in vertex A because we know that's a point on the line, and we'll sub in our slope we just found in step 2. So y equals mx plus b, and then if I'm looking at vertex A, my y value is 4. The slope we just calculated is a negative 1/2, and my x from vertex A is negative 3 plus b. So a negative 1/2 times a negative 3 is a positive 3/2. And I'm just going to change this to a decimal to make it a little easier. So I'm going to minus 3/2, which is minusing like a 1.5 to the other side. So we'll get 2.5 equals b. Okay, so we have our slope. We have our y-intercept. So step number 4 is we're just going to write the equation. So we can say, therefore, the equation of the altitude is y equals, and I'm going to make everything decimal since we did with our y-intercept, negative 1/2, or negative 0.5x, plus 2.5. Okay, so we've looked at finding the equation for a median. For an altitude, we have one more to look at. Okay, so let's take a look at a perpendicular bisector, and what does that mean? The big difference between a perpendicular bisector and the other two lines we've looked at today is that a perpendicular bisector does not need a vertex. So, does not need a vertex point. It's essentially a combination of a median and altitude. It's going to cut a line in half, and it's going to meet it at a right angle. So if I was going to look at BC and I was going to kind of guess where the midpoint was, I would say it's like maybe somewhere there. So if I was going to draw a line through that midpoint, okay, we're going to draw a line through that midpoint. It's going to cut BC in half. It's also going to make a right angle with BC. So you can see it doesn't need a vertex to come off of. So let's just write down what a definition of a perpendicular bisector is. Okay, so our perpendicular bisector is a line that divides a line segment into 2 equal parts at a right angle. Right? So again, we're going to work to finding the equation. How do I find the equation of that perpendicular bisector? So just like every other line, we need our slope, we need our y-intercept, but right now I don't even have a point on the line. So the first thing we should do, because we don't even have a point, is there a way I can find a point on this line? And because we know that it's halfway, or it's the midpoint between B and C, that's going to be the point we're working to find. So first we're going to find the midpoint of BC. Okay. Once we have the midpoint of BC, we still can't find the slope of our perpendicular bisector, but we can find the slope of BC, and we know that that's connected to the slope of my perpendicular bisector. So let's just try to find the information we can. So let's find the slope of BC. And then because our perpendicular bisector and BC are perpendicular to each other, we can then calculate the slope of that perpendicular bisector. So we'll find the perpendicular slope for the bisector. All right, so then once we have slope and we have a point from the midpoint, we can work to find our B value. So we'll find B value for the perpendicular bisector. And then our last step is going to be to write the equation. All right, let's give this a try with an example. So find the equation of the perpendicular bisector of the line segment joining G and H. So again, I'm going to give it a rough sketch. Remember, we don't need a vertex for a perpendicular bisector. So we have points G at -2 and 1, and H is at 6, 5. So I'm going to just draw a rough line, and we have H is at 6, 5, and we have that G is at -2, 1. All right, so I'm going to draw a perpendicular bisector. I'll draw it in another color so we see that that's what I'm trying to find the equation for. So we'll give this a perpendicular bisector, meaning it's going to meet there a right angle, and it's also going to be the midpoint of GH. Okay, so let's give our perpendicular bisector some points as well so we can refer to them. So we'll call this A and B for now. For step one is we're going to find the midpoint. So let's go ahead and do that. Let's find the midpoint of GH, right? Because if we find the midpoint of GH, that'll give us a point on our line of AB. So we've done lots of midpoint. Go ahead and pause the video and see if you can find the midpoint of G and H. Okay, so hopefully you got 2, 3 for your midpoint. Remember, this represents a point on the line that we're trying to find the equation for. So let's call this point C. Okay, so I'm going to call this right here point C, and I'm going to write it up here so that we can refer to it when we need to in future steps. So we're going to call that point C. Okay, so step 2 says we're going to find the slope of the line that we have the information for. So let's find the slope of GH. Again, go ahead, pause that video and give it a try. Okay, we should have gotten that the slope was 1/2. So the third step, because we have the slope of GH now, but really what we need is we need the slope of our perpendicular bisector. So now that we have the slope of GH, we know that the slope of our perpendicular bisector is going to be a negative reciprocal. So we're going to find the slope of AB, which is the line we're working towards, and we know this is going to be perpendicular to GH. So the slope for AB is going to be, I'm going to take that 1/2 that I determined in the previous step, and I'm going to flip it, and I'm going to change the sign. So it's going to become a -2. All right, step 4 is we need to find our B value. So we're going to sub in, we'll sub in point C, that's the point we determined, and we'll sub in our slope. So y equals mx plus b. Okay, you sub in point C and your slope and see if you can work to find your y-intercept. So when you subbed in point C and your slope, hopefully you got that your y-intercept was 7. And then the last step is just to write the equation. So we can say, therefore, the equation of the perpendicular bisector is y equals, my slope was -2, and then x plus my y-intercept of 7. Okay, so 3 new lines we looked at today. We looked at median, altitude, and perpendicular bisector. The steps are similar. We're pulling together that information we know about midpoint, perpendicular lines, slope, writing the equation of a line, kind of combining it all into one. That's it for your note for today.